Hi, in this video we are going to talk about the concrete implementation of the first graph traversal algorithm, the so-called breadth-first search. So I'm going to create a new project, a simple Java project. So double click on the Java project. We are going to use as an execution environment the Java SA stands for Standard Edition 1.8. For example, graph algorithms, I'm not sure. I don't want to change my perspective. And basically I'm going to create a new package for the breadth-first search. And we are going to create three classes. The vertex class is going to represent the vertices in our graph. We are going to have a breadth-first search BFS class. It's going to store the algorithm itself. And we are going to have an application.java from which we are going to test our application with the main method. Okay, so what about the vertex? The vertex is going to have a private integer data. We could store a string, or you could make this vertex generic and you can store a custom object as the data, whatever, but just for demonstration purposes, it's going to have an integer. Of course, we are going to focus on the algorithm itself. So in this case, it's going to have an integer as the data. Then I'm going to have a Boolean visited to be able to check whether we have visited this vertex or not. And we are going to store the neighbor vertices in a list. So we are going to have a list of vertices with the name neighbor list. Okay, we have to import the java.util.list. I'm going to have a constructor, and in the constructor it's going to get a data. So integer data. Of course, we have to set this.data to be equal to the data, and we have to instantiate this neighbor list in order to avoid null pointer exception. Okay. Basically, I'm going to have some getters and setters for this field variable, so the data, the neighbor list, and the visited. I'm going to override the toString method. I'm just going to return this.data. Of course, we have some string. Okay. And I think that we will have a method public void add neighbor vertex with a vertex this dot neighbor list dot add, and we add the vertex. So basically, if it's not clear that why do we need this neighbor list? So let's suppose that we have a graph made out of 5 vertices, the 1, 2, 3, 4, and 5. So basically the data is this integer, the 1, the 2, 3, 4, and 5. And we have several edges. Basically, as you can see, it is a directed graph, so we have some edge pointing from 1 to 2, 1 to 3, 1 to 4. We have a single edge pointing from 2 to 1, pointing from 4 to 3, pointing from 5 to 3 and 5 to 2, and so on. So what's going to be the content of the neighbor list when we consider the vertex 1? You can see that it has 3 neighbors, the 2, the 3, and the 4. So the adjacencies list is going to store 2, 3, and 4. Let's suppose the fact that we are considering the vertex 3. It doesn't have any neighbor, so the adjacencies list is going to be empty. What about the vertex 2? It has a single neighbor, the 1, so the adjacencies list is going to have a single element, the 1. Basically, this adjacencies list is the same as the neighbor list, whatever we call it. Usually we call it adjacencies list. Okay, and the 5 has 2 neighbors, the 2 and the 3, so the adjacencies list is going to contain 2 items, the 2 and the 3. So basically, this is why we need this list of vertices with the name neighbor list, and it's going to contain all the neighboring vertices. That's going to be the neighbors of this vertex. Okay, what about the BFS, so the breadth first search algorithm itself? Basically, it is very easy to implement breadth first search. I'm going to have a method BFS, and of course we have to specify the route from where we are going to start our algorithm. So we specify a vertex, and it's going to be the starting vertex. For example, I call it the root. Then we have to use a Q as the underlying abstract data type. So Q vertex, for example with the name Q, is equal to a new linked list. I'm not sure whether you are familiar with data structures, but basically a linked list implements the Q interface because we can implement the Q with the help of linked lists. So I'm going to import the Q java.util.q. So because the linked list is a queue, we can instantiate the queue as a linked list, and we end up with the linked list implementation of the queue interface or the queue abstract data type. What is a queue? A queue is basically something that has the so-called FIFO structure. So the first item we insert is going to be the first one we take out. So this is the queue. And basically I'm going to set the route to be visited, so that's why we created this setVisited method. It's going to be true. And while this queue is not empty, so while the queue is not empty, we are going to get the actual vertex from the queue. It's equal to the queue dot remove. It's going to remove the actual vertex from the queue, and because the queue has a FIFO structure, the first item we insert is going to be the first one we take out. Of course, because this while loop is never going to run if we implement breadth first search like this, because the queue is empty. So we're going to queue.add the root. We are going to insert the root into the queue. And while the queue is not empty, we are going to remove the actual vertex. We are going to print out the actual vertex plus some spacing. Okay, some spacing, for example. Then we are going to visit all the neighbors of the actual vertex, and we can do it with the help of a for loop. Vertex v, for example, actual vertex dot get neighbor list. That's why we implemented this. And basically, if the vertex is not visited, so if we haven't visited the neighbor, then we are going to, first of all, we set visited, and then we are going to add it to the queue. So queue.add the v. So what does it mean? That first we have to define a queue abstract data type, because linked list is a queue. We can implement the queue abstract data type with the help of a linked list. We can instantiate queue like this as a linked list. We set the route visited because we start there. Then we add it to the queue. And while the queue is not empty, we keep getting the actual vertex from the queue. And we keep visiting all the neighbors of the actual vertex, and if we haven't visited that vertex, we are going to visit it, and then we are going to add it to the queue. And basically that's all about the breadth first search. As you can see, we can implement it very easily. It's a very compact code. So let's see whether it's working fine or not. I'm going to instantiate this BFS is equal to a new BFS. Okay, I'm going to have several vertices. Vertex 1 is going to be a new vertex with the ID or the data 1. I'm going to have 4 more of them. So vertex 2, 3, 4, and 5. I'm going to rename them as well. And I'm going to set, for example, the vertex 1 dot add neighbor vertex, and I'm going to specify, for example, the vertex 2. Then I'm going to copy and paste it. So I'm going to add, for example, to the vertex 1, I'm going to add another neighbor, the vertex 4. Then, for example, the 5 and the 3, I'm going to add to the vertex 4 and the vertex 2. What does it mean? It means that the vertex 1 is going to be the root. So whenever we call the BFS on the vertex 1, it means that this vertex 1 is going to be the root node. So we start the breadth-first search here. And because we specified that we add neighbor vertex 2 and 4 to the vertex 1, it means that the vertex 1 has two neighbors, the vertex 2 and the vertex 4. So we start at vertex 1. We should get 1 because we visit it. Then we visit its neighbors, the 2 and the 4. It's very, very important that when we implement breadth-first search and depth-first search, there are two valid implementations. The vertex 1 is going to have a list, and the list will have two items, the vertex 2 and the vertex 4. But the order is optional in the sense that it can have vertex 2, vertex 4, or vertex 4, vertex 2. But as far as breadth-first search is concerned, it doesn't matter whether the vertex 2 is the first one or the vertex 4. So the vertex 1 will have the vertex 2 and vertex 4, the vertex 4 will have a single neighbor, the vertex 5, and the vertex 2 will have a single neighbor, vertex 3. So let's see whether it's going to work fine or not. I'm going to save it. So the order will be 1, 2, 4, 3, 5. And it's going to be okay. This is exactly how breadth-first search works. We visit the first layer, basically the root. Then because we add the neighbors to the vertex 1, we are going to visit the neighbors of the vertex 1, the 2 and the 4. The 2 and the 4. Then we are going to visit the neighbors of the root, which are basically the 3 and the 5. So it is working fine. Feel free to check the working of the algorithm on much greater graphs, and it's going to be clear. So that's all about breadth-first search. Thanks for watching.